Hello everyone, welcome to the presentation of our paper, The Power of Linked Eye Movement Data Visualizations. This is joint work with Burch, Broeks, Lulof, Piree, Nynke, Boonstra, Vlaswinkel, Silke, Franken, and Wijk. My name is Günter Wallner, and I'm happy to present this work today on behalf of all my co-authors. Nowadays, sophisticated technology makes it comparably easy to apply eye tracking in many different domains. However, data sets on eye movements can quickly become very large, which makes it challenging to analyze them. In this regard, visualizations have become an important part to explore, analyze, and draw insights from the collected data. And as such, different visualizations ranging from heat maps to scan paths have been proposed over time. Relying on a single visualization only can, however, be limiting, as each type of visualization only provides a certain perspective on the data. In this work, we developed a tool that supports several linked interactive visualizations to be able to inspect the data from different angles. Our design goals were to create an easy-to-use, versatile tool that can be easily accessed through a web browser. It should support different types of visualizations, and it should allow the user to also save the analysis progress and be able to share it with others. On this slide, you can see the graphical user interface of the tool, which consists of two parts, the navigation menu on the left and a page of panels on the right. The layout, order, and the amount of panels can be fully customized. Individual panels are also resizable, and they support their own settings and filter options. A panel can hold multiple visualizations, which are indicated as tabs at the top left of each panel. And a user can choose which visualization technique to use within a panel by means of a drop-down menu. This way, the user can juxtapose multiple visualizations to ease comparison tasks, for instance. The tool also supports a range of interactions, such as different ways to select and filter the data. And since the views are linked with each other, selections, for instance, are synchronously applied to all the visualizations. Currently, the tool supports 4 types of visualizations. A density plot allows the user to obtain an overview of the data distribution with the contour lines indicating areas of varying attention. The 3 colored rectangles you can see in this example here represent areas of interest which can be defined by the user. The sequence in which the elements were fixated by someone can be reviewed using a scan path visualization. And here, the size of the nodes corresponds to the duration of the fixation, and the numbers indicate the sequence. Furthermore, users can select a bee-swarm visualization to observe the fixations over time. In this case, the fixations are represented by small dots with the ID of the participant. It's animation-based, and the animation can be controlled using a slider and different buttons. And lastly, a scarf plot is provided to convey which areas of interest were observed in which order. It makes use of the user-defined areas of interest, with the areas being encoded with different colors. To get a first feedback on the tool and to assess its usefulness, we conducted a short, about 15-minute online questionnaire asking participants to explore the tool and solve different tasks with it. The questionnaire was provided with Google Forms, and it started with a short introduction of the purpose of the study, a brief explanation of the tool, and we also obtained consent from the participants at that stage. Afterward, participants were asked to rate the self-perceived expertise with respect to eye tracking and visualization. And in total, we received 10 responses, with almost all indicating high expertise in visualization, while in terms of eye tracking, the sample was a bit more diverse. Next, the participants had to solve 4 tasks with the tool. And for each of the tasks, we required to indicate their solution the visualizations they have used to solve it, and how difficult they perceived the task. And lastly, we asked for general feedback with respect to the usefulness and the current benefits of drawbacks of the tool. For the tasks, we used an existing dataset from an eye tracking study on metro maps, of which you can see several different maps here. Using some of these, we asked participants to solve 4 tasks, as summarized on this slide. One task focused on identifying highly observed locations, 2 focused on comparisons, and 1 specifically asked about the temporal aspect. Participants rated most of the tasks on the upper half of the difficulty scale, with 1 being very difficult and 7 very easy. This suggests that the system facilitated solving the tasks, and among the 4, task 4 was considered the most difficult one. The table also indicates how many visualizations were used by how many participants, and offering multiple views appeared indeed helpful for solving the tasks, as participants frequently relied on 2 visualizations. The only exception was task 4 again, which asked about the temporal behavior. And here participants relied mostly on a single visualization only. For task 1, identifying highly observed areas, the main preferred combination was a density plot together with a bee swarm. For comparisons based on the areas of interest, participants mainly combined the density plot with the scarf plot. And for the other 2 tasks, participants used a range of combinations, so there are no clear preferences in those cases. Among the 4 different views, the density plot and the bee swarm were considered highly useful by the majority of the respondents. Opinions differed, however, for the scan bar and the scarf plot, where the ratings were rather uniformly distributed over the rating range. Qualitative feedback in brief indicated that participants mainly appreciated that the tool is easy to understand and interact with, and that it offers multiple linked views with 4 mentions each. Drawbacks were mainly with respect to the general usability, and here participants offered several suggestions for improvement. More results can be found in the paper, but in general, the user study suggests the usefulness of providing linked customizable views. And it also showed multiple ways of moving forward with the tool. That's it from me. Thanks for joining, and I'm happy to take questions.